Swayam Prabha. Digital India. Educated India. Swayam Prabha. Digital India. Educated India.
Let us look at one of the most challenging and also the most interesting aspect of operations of an airline, which is scheduling and disruption management. So, there are two components to this topic. One is the airline scheduling and the other is that these schedules are probably not going to be followed to the T every time because of so many uncertainties in the airline operational scenario. So, when their schedules are disrupted, what can be done to manage the disruption to the maximum possible extent? First, let us have a look at how airlines schedule the flights. So, what is airline scheduling? It is a very interesting and a very complicated activity. It is the art of designing system-wide flight patterns, and the aim is to provide optimum public service to the passengers, but at the same time to ensure that while providing the optimum public service, the airline also maintains financial health. In other words, the costs incurred by the airline in arriving at these particular schedule and following these schedules should not be so large that it hits the bottom line of the airline to a great extent. So, a balance has to be created between the public service that you are giving and the airline's financial health. There are many factors which affect scheduling. Let us have a look at some of them very quickly. The first are the internal factors, factors which are within the purview of the airline, so to say, not dependent on external factors. What are these? Every equipment that is operated by an airline, mainly the aircraft, they require some maintenance. This maintenance schedule is pre-worked in an agreement with the original equipment manufacturer, regulatory bodies and the airline maintenance procedures. One of the very important aspects of an airline's scheduling is to optimize the utilization of the crew members, both the cockpit crew and the cabin crew. So, the efficiency of the utilization of the crew is an important aspect. Then there are some constraints within which an airline operates, such as the gate positions and the ticket counters. Okay. So, these have to be kept in mind. Then there are many other marketing factors. For example, how much traffic is expected, what is the demand that you are expecting on various routes, what is the load factor that you would like to operate, what are the other airlines operating the same route in competition with your route. Then we look at flight operations and the fuel capacity. You cannot just send any aircraft on any route. It should have the capacity to take those many passengers with their baggage and cargo to the destination. And finally, we need to factor in the effect of climate. The climate changes a lot during summer, during winter, and that is why many airlines, in fact most airlines, they actually release a separate schedule for summer and a separate one for winter, as we shall see. Then there are certain external factors which are not in the control of the airlines. There could be flight curfews at an airport. There are windows during which you are not allowed to operate, primarily determined by the community living near the airport, which pressurize the airport authorities and the regulatory bodies to create these curfews. For example, in Europe we see that there are no flights normally scheduled for passengers between say 11 p.m. to morning 6 a.m. Then the local community, yes, they do not want to be disturbed, so there might be some restrictions on number of flights operating per hour during the peak times. Then there are some constraints which come from the operators of hotels and motels. These are also the stakeholders in the air transportation system. Travel agents have their own considerations, their own constraints, their own requirements, and the air freight shippers which provide you with the ability to carry belly cargo, which improves your bottom line, they also have some constraints, they also play a role. So, both internal factors and external factors together they influence the scheduling. Then there are going to be competitive airlines. At busy routes there will be more than one airline operating the same sector or the same sectors, and each of them will be aiming to lure the passengers into their route or network as compared to the competition. So, they also create some pressure, and sometimes scheduling has to be adjusted or created a priori to respond to the competition. With all these constraints, ultimately you come out with a schedule which is called as a carrier or an airline schedule. Now, let us look at all these factors one by one. If we sum up the whole task of scheduling, it comes into 4 major tasks which are normally done sequentially. Let us see what these tasks are and what is the specific job to be done in each task. The first of these is schedule generation. In schedule generation, what you normally are expected to do is to come up with a timetable. That timetable has to be competitive, or it has to be created keeping in mind the competition. And what is the aim of this timetable? It should be such that the potential demand is met, and there has to be some buffer in the schedule to ensure that if there are some delays which are not in your hands, then it should be possible to recover from these delays. The next activity is fleet assignment. By fleet assignment we mean that you have to assign an aircraft type. An airline may have many aircraft types depending on the routes, depending on the markets, depending on the requirements, and therefore among the various kinds of aircraft, various capacities that they have to assign an aircraft type to fly on each sector, and the aim is to maximize the revenue. So, this is called as fleet assignment. Once the schedule is generated, one has to assign various fleets to that particular schedule. The next task is aircraft routing, and that is sequentially what will be the route followed by a given aircraft, and also which aircraft will fly on which particular route. Among the pool of aircraft, assigning a particular aircraft on a particular route and working out its continuous schedule for the day, that is called as aircraft routing, which is only possible after we do fleet assignment, which is possible after doing schedule generation. And once you assign an aircraft on a particular route, then the next important task is called as crew rostering. Crew rostering basically means we assign the flight duties to specific crew members, again to maximize the resource efficiency. So, everywhere the bottom line is that the resources should be optimally utilized and the revenue should be maximized. That is the whole focus of airline scheduling, keeping in mind the factors which are internal as well as external and as well as from the competition. So, now what we will do is we will look at each of these 4 tasks in little bit more detail to realize how complicated and involved this particular aspect of operation of an airline is, that is the scheduling. So, let us first look at resource utilization and synchronization. Resource utilization is a very loaded word, okay, and this is the key goal of airline scheduling. In fact, one can say that the principal aim of airline scheduling is to ensure that the resource or the resources at the disposal of the airline are optimally utilized. What are the resources? The crew members are the resources, the aircraft are the resources, and the various facilities at the airport, the various equipment at the airport, they are the resources. All of them have to be optimally utilized. The maintenance facilities, etc., they are also resources. So, the reason why this is important is because aircraft and crew, among all the factors mentioned, they are very expensive resources. It is not a small amount. Okay. So, a typical experienced captain on an airline flying international routes with large aircraft, wide bodied aircraft, can cost an airline upwards of $250,000 a year, and if you do not utilize the resource within the constraints efficiently, you are incurring a huge amount of expenditure, and if you do not do it properly, it is a sure shot recipe for disaster. Then not only you are supposed to utilize the resources, you need to synchronize them with each other so that they work in proper arrangement together. Okay. So, for that we have to pair and match resources that can't operate independently. For example, you may have an aircraft and you may have a crew member, but this crew member may not be authorized at that point of time to fly this aircraft. So, these two resources are there, but they can't work independently. Similarly, there may be a crew member who is available, but not matched properly with the other resources which are available. So, pairing or matching of resources that cannot operate independently is a very important aspect of resource synchronization. Okay. So, what do? We first generate a timetable, okay, and then you do synchronization. What do you synchronize? Many things. First and most important is you have to synchronize the aircraft fleet that you have with the flights that you are going to operate as per the schedule, right. Then you need to synchronize the flights with specific aircraft and passenger itineraries. Okay. Then you need to do crew pairing, where you have to match the aircraft with the cockpit crews. As I said, not every crew member can fly every aircraft at any given point of time. And finally, we need to create a roster for each crew member and for each crew pairings, so that they are optimally utilized without wasteful expenditure. So, all this synchronization has to be done, and it is not very easy, and therefore, this activity is very much prone to mathematical modeling, as we will see. Let us look at the first task, which is the schedule generation, also called as timetabling for an airline. So, how do you generate a schedule or timetable? Obviously, it is based on how much demand is forecast on each sector and what proportion of this demand is expected to be covered by you depending on your market share. Okay. So, Dij stands for the demand for travel from a city I to city J. Okay. So, for each sector you need to calculate or estimate or forecast the value of demand. Now, if your forecasts are accurate, if your assessments of market shares are accurate, then your schedule will be very well matched with the actual passengers who come. But if there is a mismatch, if you under predict the demand or over predict the demand, then you are going to operate inefficiently. So, this is a very important aspect which also hits the bottom line very badly. So, what we decide is we decide the departure time for each origin destination pair, and not only the departure time, we also decide the frequency. By frequency I mean how many times do you operate on this particular OD pair. OD stands for origin destination. How many times in a day is a flight offered from some origin to some destination, that is called as frequency. It could be a daily frequency, there could be weekly frequencies. Okay. So, now obviously this frequency is going to be nothing but the division of the demand between a particular starting point or origin to a destination divided by the capacity into load factor, because capacity into load factor will tell you how many people are expected to be carried or transported in each flight on a particular sector, and when you divide it with demand, you will come to know how many flights have to be operated. Obviously, frequency has to be a whole number. So, if the result of frequency is 3.28, it means you need to operate 4 flights, with one flight probably or all flights probably going with not full. So, passengers love to have higher frequency. So, whenever a passenger sees that an airline is operating higher frequency on a particular route, it is very appealing for them, because then they can plan their journey accordingly. Although leisure passengers are not very much concerned about the time of the flight, because they are more concerned about the fare and the amount that they have to pay. So, they might not really be too much bothered, but even they also are very happy if the frequency is more. Business passengers definitely prefer and love higher frequency, because that allows them to adjust their time. So, it is very straightforward. Look, if you have, for example, if you have 60 passengers from a start to a destination, if you operate an aircraft with 60 seats, you are going to have one flight a day. So, everybody has to adjust their departure with the departure that you decide. If on the other hand you use a 15-seater aircraft, you can have 4 flights in a day, which will be spread over the day. So, therefore, you will be able to get more. Sometimes an airline may club 2 or 3 flights almost within a short duration because of the huge demand expected at that particular time. But generally it is seen that if you operate higher frequency, because of the passenger appeal, you get higher market share on that particular sector. Secondly, schedule is something that the passenger would like to know much in advance. Okay. So, therefore, generally all airlines come up with their schedule twice a year. There is a winter schedule which goes from October to March, and then there is a summer schedule which goes from April to September. It is quite possible that depending on the nature of the travel on particular route, nature of the demand on a particular route, an airline may offer more frequency in summer and less during winter, or vice versa. That depends on the assessment of the airline, what is their model and prediction about the demand on each sector. Okay. So, generally an airline publishes the schedule twice a year, which passengers are aware in advance, and then they can decide which flight to take. Interestingly, although the schedules are generated twice a year, which means passengers generally have about 6 months notice to book their tickets, but in reality it has been seen that even though they had announced their schedule 8 to 10 months in advance, it is normally seen that most bookings take place only about 90 days before the departure date. There are very few bookings 3 months before the departure, although schedule is available. So, much of the activity starts happening in the last 90 days, then 60 days are more hectic, 30 days are further more hectic, and last 15 days could be very, very hectic. Okay. So, generally, as you know, the business passengers would like to delay the date of their booking, because they themselves are not aware exactly when they would like to travel, and they are also not so sensitive to the fare. On the other hand, the leisure passengers are interested in lower fares and they do not mind booking very much in advance. Okay. It is an interesting exercise to decide which size aircraft to operate on each route and hence a frequency to operate on that particular route. Okay. So, let us take an example. Example is of an airline called as the Faltu Airlines. Okay. This airline predicts a daily demand of 1000 passengers from a city AAA to a city BBB and back. In other words, it expects that there will be 500 people who will travel from AAA to BBB and there will be 500 people who will travel from BBB to AAA every day. This is their prediction. Now, if that is the case, then another thing to be known is what is the nature of the airline. So, this particular airline, the so called Faltu airline, let us assume that it offers a single class cabin. All the seats are economy seats. Okay. There is no business class, there is no first class, everybody is flying in economy seats. Okay. So, now let us have a look at the information and then decide. So, assume that this particular airline has 3 types of aircraft. It has a few aircraft of Airbus A380, few of Airbus A330 and few of Boeing 787. Now, the Airbus A330 is configured by this airline to have a maximum capacity of 550. The A330 is configured to carry 280 passengers and Boeing 787 is expected to carry 200 passengers. So, you can notice that the demand from one point to the other or from one city to the other is about 500 passengers each way. So, if you look at the frequency that can be offered, obviously A380 will not be operated more than once a day on each direction, because if you operate it more than twice a day, it will only going to go half full, because the demand is 500 and the capacity is 550. On the other hand, if you operate an Airbus A330, you can have 2 flights from AAA to BBB and 2 flights from BBB to AAA. So, the frequency on each route will be 2, because it has got 280 capacity. So, when it flies 2 times, it can carry 560 passengers instead of the 500 passengers which are expected. The next option we have is a smaller aircraft B787, which is configured in this airline for 200 seats. Please note, these capacity numbers are not fixed. Different airlines can configure the aircraft to have different capacity by adjusting the seat pitch, and that is a function of the marketing of the airline and which kind of market, which kind of segment of the market they are addressing. Okay. So, in our case we are looking at all economy seats, single class cabin. So, they are able to fit in 200 passengers in Boeing 787, and with that they are able to offer 3 flights a day from AAA to BBB and 3 flights from BBB to AAA. But while doing that, we realize that the number of seats which are available is more than what is required. What is required is 1000 passengers a day, but the seats available are 101, once again, the seats available are 1100 or 1120 or 1200 seats, depending on which aircraft you fly. Now, because of the number of seats available being more than what is needed to meet this demand, you have an excess capacity on each route. So, if you operate Airbus A380, you have a excess capacity of 100 seats a day. If you operate A330, you have 120 seats. If you operate Boeing 787, you have a whopping 200 seats extra. Okay. So, now what do we do? Let us look at also another important aspect, that is what is the cost per seat. Okay. So, Boeing Airbus A380 being the largest aircraft, it will have higher operating cost among all 3, but when you divide by number of passengers, it will have the lowest value. So, it is the lowest seat per pax per kilometer. 330 will be the medium because it is of the medium capacity, and 787 among these three will have the highest value. Okay. So, now if you are in the scheduling department and if you are supposed to assign one of these three aircraft, which one would you suggest? Would you suggest that they should go for Airbus A380, which gives you a very small excess capacity, but the least frequency of 1. However, it has the lowest seat cost of operating passenger per kilometer, and therefore it will have the least expenditure for the airline? Or would you go for Airbus A330, which is going to give you double the frequency, but the number of seats is also slightly more, 20% more to 120 seats? Or would you prefer to go for Boeing 787, which gives you a frequency 3 times or 3, but ends up with the highest number of seats? So, if I were to decide, I would go for Airbus A330. Why? Because Airbus A330 is giving only about 20 more excess seats compared to A380, but double the frequency, and it also has got the median value of the cost per seat. So, remember that demand is always a variable. When an airline predicts that there is a demand of 1000 passengers, it does not mean that it will be actually 1000 every day. It can range plus minus some number. So, with A330 on this route, you will be able to give a reasonably good frequency to the passengers, that is twice a day. You will also be able to have slightly more number of seats available than what you predict will be useful. So, in case the demand goes up, you can take advantage of that by using the excess capacity which you have. Okay. And the medium cost per seat also is helpful, because the operating cost will not be very high or very low. So, the middle path in this case seems to be the most appropriate one for this particular route. But remember, this airline is offering a single class cabin with all economy seats, and depending on the operating scenario, it may say no, we are going to go, we are going to compete in the market, we are going to have other airlines vying for our passengers. So, let us operate with only one frequency in a day, see if it gets filled up. Maybe we can leverage by yield management the revenue, and we will have the least excess capacity, although it will also not allow you to be attractive for the passengers because you have only one frequency. 3 frequency per day is attractive, but remember, scheduling has to also keep in mind the financial health of the airline. Operating a frequency of 3 with Boeing 787 on this route is going to lead to a lot of excess capacity, in this case 200 seats extra than the needed, and also the cost per seat is the high. So, the airline also will incur more expenditure. So, that is why the middle one, A330, seems to be a good choice for this particular route. Let us now move to the next aspect, which is the fleet assignment. So, the fleet assignment process basically aims at allocating the available aircraft capacity to meet the potential demand, and the potential demand also drives how much capacity should be allocated. So, it works both ways. Right. The aim obviously is to maximize the potential profits which are earned by the airline. Okay. So, what you can do is you can use aircraft of different capacities on different routes. So, on the trunk routes, if you are operating hub and spoke type of network, you will have traffic between 2 hubs. Those 2 hubs are going to collect passengers from the spokes and then transfer them to the hub. So, there will be a requirement for larger capacity. So, you use a much larger aircraft on these trunk routes. The problem is then the frequency will reduce. However, when you have thin routes or routes where the expected demand is less, there you use a smaller capacity aircraft because it will allow the frequency to go up. Now, ideally speaking, it would have been nice if on routes where there are many passengers, you are able to offer a better frequency, so that these many passengers have much more choice. The problem is you cannot do that, because then you will be flying with lot of excess capacity, which comes with a huge overhead. On the other hand, if you assign a large aircraft to thinner routes, then again it will fly mostly empty, because the capacity that can be filled up is going to be much lower, because they are thin routes, the demands are low. So, what you do is, by assigning larger aircraft to the trunk routes and smaller aircraft to thinner routes, you automatically take care of the requirement of maximizing the potential. This is an inherently challenging problem. Why is it so challenging? Because the demand forecasts are uncertain. However, you cannot adjust the aircraft size too much to meet the demand. In theory, it is possible to push a few more seats in an aircraft by reducing the seat pitch, but this process takes time. So, maybe it will need a few hours to adjust the seats, and passengers are going to book their tickets in advance, right. So, many of them also choose a particular seat in advance. So, therefore, reconfiguring the aircraft for each flight, though technically possible if time permits, time between flight permits, not really a very practical method all the time. So, one can assume that the aircraft capacity is fixed, but the demand keeps arbitrarily fluctuating. It fluctuates based on season, it fluctuates based on competition, it fluctuates based on certain events that take place, and the airline has absolutely no control on how much the demand will actually be implemented in each flight. So, that is why, because capacity which the airline can offer is fixed and demand forecasts are uncertain, they have to invest a lot in coming up with accurate demand forecasts, and that is why this particular exercise is a very inherently challenging problem. Let us look at a typical challenge in assignment of fleets on specific routes. Once again, let us assume that there is an airline called Bakwas Airlines. It predicts a daily demand of 210 passengers from a city CCC to a city DDD and back. So, in each direction it expects 210 passengers. However, as I mentioned, demand prediction cannot be absolute, it is uncertain. So, let us assume that this demand of 210 passengers, based on market studies, based on past data, let us say that there is a fluctuation in this of plus minus 25%. So, it will be a normal curve distributed across the mean of 210, one extreme will be 185, one extreme will be 235. That means, the number of people who actually turn up for a specific flight could range between 185 and 235, but the mean value is 210 passengers. Now, once again, the airline operates two aircraft type, there is the Airbus A320 and Boeing 737. Now, the aircraft are configured in such a way that A320 in this case can carry 240 passengers and 737 can carry 180 passengers. These are just illustrative numbers, okay. Don't worry too much about tying up the numbers with the aircraft, because as I mentioned, you can reconfigure the cabin to create more seats or less seats to an extent by adjusting the seat pitch. So, let us assume that the airline can offer either 240 seater A320 on this particular route from CCC to DDD, or it can run a Boeing 737 with 180 seats from CCC to DDD. We have to choose between one of these two. Since the demand is uncertain, the lowest estimate of the demand is 185 seats. If that happens, then Airbus A320 is going to have an excess of 55 seats. But when you operate Boeing 737, you are going to send away 5 passengers, because you can't accommodate 185, you have only 180 seats. So, the extra seats are minus 5. On the other hand, if the demand is such that it hits the upper limit of the prediction, which is 235, then you have only 5 excess seats in Airbus A320, but you have 55 seats less in Boeing 737. Okay. So, now if you look at the load factor that is operated by the aircraft when the demand is low, the load factor is going to be only 77% for A320, because you are going to operate 185 seats out of 240 seats. So, that number is close to 77%. In case of Boeing 737, it will be 100% load factor, because you will fill the whole aircraft with 180 passengers, and unfortunately you have to send 5 passengers away. If on the other hand you are operating with demand at the upper end of the prediction, that is 235, then the load factor with Airbus A320 is going to be 98%, which is 235 by 240, and it will be 100% again for 737, because obviously you are short of 55 seats for the passengers. So, you will go full, but you will leave behind 55 possible passengers. Okay. Now, the total operating cost per route is going to be more for A320, because it is a larger aircraft, and it will be less for Boeing 737. So, the question is, which aircraft type would you recommend for this route and why? So, now that is a very difficult question. The answer is not really either 320 or Boeing 737. Okay. It all depends on what is your strategy to handle. It all depends upon what are the routes available, what are the requirements for the next sector, because this same aircraft will also fly to the next sector. Once it goes from CCC to DDD, it may go from DDD to some other place, maybe back to CCC, maybe some other place. So, that also should be factored into when we decide which aircraft. We need to look at the overall operational and not just flight by flight. So, it is a difficult question to answer, but in general to me it seems that we should go for A320, because you are operating at almost full load factor at the maximum demand, and yes, you have 55 seats extra when your demand is very low, but what can be done is, when you know that you have less seats filling in, then you can use some yield management strategy to improve your load factor. So, it is a tough choice, it is not very easy for us to arrive at a conclusion. So, the load factor has a huge leverage in schedule planning and coordination. Any empty seat in the aircraft is going to be an opportunity lost for an aircraft. Okay. So, you have to be very careful when you do the scheduling. You have to look at the operating cost of the aircraft versus the load factor loss or change in the load factor. So, the empty seat is a problem for an airline. So, a very small increase in the load factor or decrease in the load factor can affect the airline bottom line in terms of profit and loss. So, one has to be very careful while planning out the schedule. Okay, now let us look at aircraft routing, also called as a tail assignment or TA in airline scheduling. What is aircraft routing? Actually, every aircraft, they have a unique ARC, the aircraft registration code, which is painted on its vertical tail and also at few other places, but the principal area is the vertical tail. So, that is why what we say is that we have to assign a particular aircraft with and its tail to a particular segment. Okay. So, tail assignment stands for assigning routing to each individual aircraft, and how it is looked at, you have to meet the maintenance requirements, but you should have some flexibility, and also you have to keep in mind that there are various levels of aircraft maintenance. Every act of maintenance is not same. There are some which are routine maintenance checks. These are normally performed either between two flights in that turnaround time period available, or in many cases they are also done overnight. In fact, both are required. Certain routine checks are required between two flights, that is called as line maintenance generally, and certain checks are required overnight, which may require about 8 to 10 hours of maintenance time. Generally when the aircraft is brought to the maintenance hangar in the night time at the end of its schedule, because of night curfews and because of less chances of passengers preferring to fly at very late night except leisure passengers, we perform maintenance at night time, and early morning 6 o'clock, 7 o'clock is when the passengers would like to travel. Then there are certain major maintenance checks. Now these are the ones that require the aircraft to be taken out of service. So if an aircraft goes for major maintenance, it is not available to the airline for scheduling, okay. But every aircraft becomes due for major maintenance at a particular frequency. After so many hours of operation, after so many months, it becomes due for major maintenance. So there is no option but to schedule in such a way that when it is coming towards its major maintenance cycle, it has to be taken out of service. So let us look at what are the maintenance checks for a typical narrow body airliner. Okay. We call them as line maintenance or check A, check B, check C, check D, etc. This is how it is referred. So let us look at it one by one and see what these are. When is the line maintenance done? Between two successive flights during the turnaround time. Check A is required after about 8 to 10 weeks of operation. Check B is required after about half a year of operation, 6 to 8 months of operation. Check C is required after 1.5 years or 2 years of operation, and check D, which is the largest check, is required perhaps after about 6 to 10 years of operation. So how much time is needed for each of these checks? Line maintenance takes place during the turnaround time, so generally between 30 to 60 minutes. Check A requires about 6 to 24 hours. Check B requires 1 to 3 days, and during this period 1 to 3 days the aircraft is not available for scheduling. Check C takes about 2 to 3 weeks of time, and check D, which is the most extensive, takes about 4 to 6 weeks of time. So just imagine, for 1 quarter or half a year the aircraft is not available to the airline because it has gone for a major maintenance check D. How much is the maintenance man hours required for each of these checks? Land maintenance is okay, just about 2 maintenance man hours, in fact even less sometimes. For a very small twin turboprop commuter aircraft, this may be just half mmh, okay. Just one person is required for half an hour to do the line maintenance, but in narrow body airliners you typically require 2 maintenance man hours. In case of check A, you require 60 or so mmh. 3 times the more is required in check B, 180, and 100 times compared to check A is required in check C, which is 6,000 hours. And for check D the number is very large, it can be upwards of 10,000 depending on the aircraft type and depending on the condition of the aircraft. Okay. Now remember that line maintenance is done after each flight, as I said, between flights. The A checks are to be normally done after about 400 to 500, 600 hours, which corresponds roughly to 200 to 300 trips, okay. Correct. Now in many cases this check B is merged with check C, because after every 6 months or 8 months taking out the aircraft for a couple of days, 3 days is not very convenient. So many a times the items to be maintained in check B, they are taken up in check C, okay, because in check C, which happens as I said 1.5 years to 2 years, you examine the whole structure and lubricate the cables and fittings. So many activities. So nowadays check B is normally merged with check C. Check D is most extensive. In fact, the entire aircraft is dismantled, every portion is checked, the internal structure of the aircraft is checked. We do a lot of non-destructive testing of the aircraft structure to locate cracks or damages, etc. and then the whole aircraft is reassembled back. It is like stripping the whole aircraft and reassembling it back. That is why it takes so much time and it costs millions of dollars. So, when an airline does check D maybe 2 times or 3 times, okay, after that it is not worth doing check D, because then the costs become very high compared to the returns. So, generally an aircraft is sold off or retired after about 2 or 3 check Ds, or 3 or 4 check Ds. Now, equipment maintenance by itself brings in a lot of constraints in scheduling. Okay. The out of service time or the OOS time is supposed to be disastrous for an airline. So, budget airlines especially are interested in minimizing the out of service time and maximizing utilization with the adequate maintenance. You cannot avoid maintenance, it is a necessary activity and it is required because it ensures safety. After all, passengers are more concerned to arrive at destination safely rather than arriving early or being more comfortable. Safety is the paramount, and safety is ensured by proper and timely maintenance. Then you have to give enough time for inspection. Okay. So, as the out of service time reduces, you need to have maximum time for inspection, right. The next important point is that the workload of the personnel who are doing this equipment maintenance, these are highly trained specialists. Okay. Even when there is a aeronautical engineer or a mechanical engineer who is well qualified, you cannot simply go and do the maintenance of an aircraft, you need to be certified. Okay. You cannot touch the aircraft unless you are licensed and certified, and that too you are certified on a particular aircraft, and that too either on the airframe or on the engine or on the electronics, you know. So, to ensure that these highly trained specialists have even workflow, we have to plan the maintenance activities accordingly. You cannot say that we will schedule a flight so that all the aircraft come for maintenance at the same time and then they are all put back in service. They have to come at regular intervals so that the workload of the specialists is not arbitrarily increased. And then of course, all of these maintenance activities, they require facilities. These facilities have to be available. So therefore, keeping in mind the availability of the facilities, keeping in mind all these factors, the maintenance schedules are worked out and configured with the airline schedule. Let us look at one example in maintenance routing, just a small theoretical example. Imagine a flight from Washington DC, which is codenamed as DCA, to Des Moines in Iowa, DSM, to Denver in Colorado. Okay. So, the aircraft now each of these airports shown in the screen, they have different levels of maintenance facilities. So, wherever you see one, everybody will have one, because that is en route service and overnight. Okay. But then some of them have A check, some B also, some C also, and some D also, right. Now, suppose an aircraft is taking off from Washington DC, and when it lands in Des Moines, there is a mechanical failure, and that failure is so severe that it requires the A check facilities, which are not available at Des Moines airport. It only has en route service and overnight. So, what has to be done now is you need to locate another substitute aircraft. That substitute aircraft may have to be flown from some other airport, or it may be available at Des Moines airport. So, the substitute aircraft is required to transport the passengers from Des Moines airport to Denver airport, and also now the aircraft which is stuck at Des Moines because it does not have A check, but the mechanical fault. Now, either we have to fly in some experts or mechanics to DSM to ensure that the maintenance is done and the aircraft is then repositioned. So, this is one important. Now, let us look at some key challenges in the tail assignment activity of an aircraft. As I mentioned, maintenance schedules have to be strictly followed because safety depends upon them, and these are regulatory requirements. Okay. So, what you should do is you should ensure while scheduling or while assigning a particular aircraft to a particular route, that whenever the maintenance is due, the aircraft arrives just in time, so that it does not unnecessarily have to wait at that particular place for maintenance, and it should not really you can't have it stranded somewhere because maintenance is needed but cannot be done. Okay. If you arrive very early at the designated maintenance base for a particular level of service, then you are wasting money because the aircraft is on ground doing nothing, waiting for the maintenance activity to start. On the other hand, if you go for too much optimization and if you plan it very poorly without giving adequate time, then it may happen that you arrive late because of some unavoidable delays, and now you have to position this aircraft in a non-revenue flight to the maintenance base after taking permissions, because if the aircraft is due for maintenance, you have to take approval for it to be flown. Generally, the approvals are given for non-passenger flights. Sometimes you can get some concessions also once in a while, but generally you will not be able to get concessions because maintenance is a very safety critical activity. Okay. So, what we need to do is we need to balance the aircraft wear and tear due to operating condition. Now, all the aircraft operated by an airline do not necessarily always fly on one particular route, they are reassigned to various routes. So, it is not a good idea that some aircraft are exposed to a lot of hot and cold conditions and some aircraft are exposed to relatively lower hot and cold conditions. It is important to distribute their routing in such a way that all of them are exposed roughly to the same kind of atmospheric conditions, so that they need the maintenance of almost also the takeoff and landing cycles. You cannot schedule a particular aircraft to have more takeoff and landing cycles compared to the other aircraft in the inventory, because then there will be too much maintenance costs on one particular aircraft and the other will have lesser costs. Okay. Let us look at a typical challenge in the tail assignment. This is a theoretical example, it is not at all based on any actual airline, it is just a concocted example to show you what kind of challenges are there. Assume that there is an airline which operates flights from Delhi, that is D, and it has to end at Mumbai, that is M, for carrying out night maintenance. Now, so the flights have to originate from Delhi. Now, assume that the operation starts from 7 AM at D or Delhi. One possible routing for the day could be as follows, that is assigning this aircraft from Delhi to Kolkata, back to Delhi, from there to Hyderabad, from there to Kolkata, from there to Mumbai, and it reaches Mumbai at 10 o'clock in the night. So, this is number 1, this is the assignment number 1, which has these 5 flights in a day. At the end of the 5th flight, it reaches Mumbai. The next option could be that you travel from Delhi to Ahmedabad, from Ahmedabad to Bhubaneswar, from Bhubaneswar to Goa and Goa to Mumbai, and you reach by 8 PM. So, here the number of flights is 1 flight less and you are reaching Mumbai at 20:00 hours or at 8 PM. The previous routing made the aircraft to arrive at 10 PM. So, route number 2 has 1 flight less, 1 leg less. Then you can also have route number 3, where it starts from Delhi, goes to Chennai, back to Delhi, and from there it goes to Mumbai. So, here you have only 3 flights in the day, and the aircraft starts at 7 o'clock and it ends up at Mumbai at 6 PM or 1800 hours. The question is based on the maintenance requirements. So, now if it is given to you that the night maintenance facility at Mumbai starts at 2300 hours and ends in the morning at 7 hours, if this is the condition, then the question is which routing will you prefer and why? So, let us look at all the issues. Number 1 routing has the maximum utilization among the 3 because you have 5 flights and you are utilizing the aircraft right up to 10 p.m. and the maintenance starts at 11 p.m. So, this might appear to be the most optimal routing for this particular aircraft on that particular day. Route number 2 has 1 flight less, it has only 4 flights. The arrival at Mumbai is 2 hours before that in route number 1, and that gives you a margin of about 3 hours before the maintenance activity starts. Route number 3 has only 3 flights, although it is a long duration flight, but it is only 3 flights. Okay. And you arrive at Mumbai at 6 o'clock and the maintenance can start only at 11 o'clock. So, you have a margin of 5 hours. Looking at these numbers, one might say that routing number 1 is the best because you are utilizing the aircraft maximum, you are having more flights and you are arriving in time for the maintenance. As I mentioned, just in time arrival for maintenance is a good idea. However, remember that when you are having an aircraft that has so many flights in a day, there is always a chance that at some of these places there might be some inadvertent delay. And if that delay builds up beyond let us say beyond 1 hour, okay, then you will be late for maintenance and you will get less time for maintenance. So, arriving just in time for maintenance as a standard schedule is not a good idea because route number 1 has got minimum scope for handling disruption. If there is a delay of let us say half an hour on each flight, you will actually end up reaching Mumbai very late and then you will not have enough time to do the night time maintenance. Route number 3, which is only 3 flights starting from Delhi, though longer flights, it is arriving much early, it is 6 p.m. Okay, 5 hours. Now, you have only 3 flights and you are keeping a margin of 5 hours, that is wasteful. So, neither one is good because you are being little bit greedy there and there is less chance for handling a delay or disruption, and route number 3 is very conservative. So, the best or the optimal routing for this among the 3 would be routing number 2, wherein you arrive at Mumbai by 8 p.m. Given that there is a delay, you will still be very much in time before the maintenance activities start. So, this is one typical challenge in the tail assignment. Okay. There are various types of schedules which are followed. Okay. For example, if you look at something called skip stop, so what it does, it goes from A to C and then from C to E and from E to G. So, it does not stop at every destination in the sector. The next one is local service. In local service, you travel from one airport to the other and you keep on traveling to all the airports and you stop, then you can probably have a change in the aircraft and then travel to the large destination. And then the third one is a non-stop service, which is the flight directly from one end of the segment to the other with a long duration flight. So, you can have various types of schedules depending on the customer demand, depending on the market you are operating, depending on what is needed, and each of these schedules are going to have their own pluses and minuses. Let us now look at crew scheduling, which is a very challenging and very important aspect of airline scheduling. In crew scheduling, we are interested to match the crewing requirements of different fleets with the routings of the crew members. So, this involves 2 separate but connected activities, which are crew pairing and crew rostering. So, what is crew pairing? In crew pairing, you have to give a series of flights to a crew member, and when I say crew member, I actually mean mainly the cockpit crew, but also the cabin crew, they also have similar things. So basically when you decide a series of flights for a crew member, they should start and end at the same location, okay, because typically a crew member would like to finish the duty and come back home. The crew member stays in a city, and if you end the routing at some other city, then you have to give accommodation and you have to incur expenses. Okay. Now this can be one day or many days. So in case it involves stay at some other locations, this whole thing can be many days, and we have to look at how much is the maximum time away from the base, which is constrained by certain agreements. Okay. You have to also meet the legal requirements. What are the requirements? There is one requirement called 8 in 24 rule. For example, what it means is that in a 24-hour period of duty, what it means is that in one particular day of 24 hours duration, the crew member will be on duty only for 8 hours, and these requirements are further changed or constrained by the crew bargaining agreements, which can be more severe than just the minimum legal requirements. So the legal requirements may be the legal requirements may impose some constraints, but the crew bargaining agreements may impose stronger constraints or larger constraints. Okay. For example, the legal requirement could be that you could fly 1000 flying hours a year, but the crew bargaining arrangement could be that no, they will only fly 800 flight hours per year or less. In crew rostering, we assign crew to individual flights. Okay. We assign the crew to individual flights, and these flights assignments are done based on certain requirements and constraints which come from various areas. One important thing is the skill, because a particular cockpit crew member or the pilot or the co-pilot, captain or first officer, they can fly only one aircraft type at a given time. They may be qualified to fly more than one aircraft type, but on a particular day or in a particular slot, they will be qualified or approved only to fly a particular aircraft type. So you need to match their availability with the availability of the aircraft. Then you have to look at the crew size limitations, because there are restrictions which say that if you have a flight of 8 hours or less, then they are operated by a 2-member crew. So there should be minimum 2 crew members available for you, and if you have a flight which is more than 8 hours, you may have to fly some crew members in the passenger cabin as passengers. This is called as deadhead crew. They are there because the requirements are more than the flight requirement. They are there because the flight duration is more than 8 hours, and therefore you need to have spare crew members available to operate. Sometimes these crew members will be resting in the crew rest areas, but many a times they occupy a seat in the passenger cabin. As I mentioned, the crew bargaining agreements could be more severe than the minimum legal requirements. Let us look at some typical crew bargaining agreements. There is something called as FDTL, Flight Duty Time Limitations. The FDTL could be per day or per week. Okay. So there might be an FDTL saying that you can do active flying for 7 hours a day or 8 hours a day, but the time when you leave your residence to go to the airport, get the pre-departure briefing and then take over the aircraft, all that is also counted as part of the duty. So there could be a requirement that the total duty time would be 10 hours a day, and in that the FDTL would be 8 hours a day. Okay. So the flight duty could be 8 hours, the total time could be 12 hours or whatever, 11 hours. Then there are negotiations between the unions and the airline for how many day offs are given between the duties to the crew members both in the cockpit and in the cabin, so that they are not tired and they remain fresh to ensure operational safety. Then after some difficult duties or duties which cause stress to human beings, you can prescribe certain minimum rest. For example, if a crew member is crossing the international date line many times, there may be a restriction that you can do it only so many times in a week. Plus, if you fly across multiple time zones, then the body gets disoriented, okay, you get jet lag, and that affects your biological condition. So, there could be certain restrictions on how many times you are allowed to cross multiple time zones. Then there are annual leaves. All of us like to have a vacation, annual vacation, where we want to refresh ourselves, to do something else other than what normal work we do. So, these leaves have to be decided and negotiated in advance. And then to ensure that there is a equitable distribution of workload among the crew members, there is some minimum guaranteed work hours per roster period. A roster period could be 3 months or 4 months, whatever. So, all the crew members who are available should be roughly equally loaded, not that one particular group of crew members are more loaded and others are having a lesser load. So, these kind of bargaining agreements are there between the airline and the union, staff union or the pilots union, which have to be kept in mind or factored in when we do the scheduling assignment. Some typical duty constraints are mentioned here. So, the captain could say that there is a daily limitation of 8-hour duty time as a member of the 2-person crew members. Then the first officer or the co-pilot can say that if I exceed this particular duty time, I have to get 8 hours rest, prior to exceeding beyond these. Then the cabin crew members will require 8 hours of rest in 24-hour period that includes a flight. This could be their constraint. Okay. Plus there may be a constraint on what happens over a week. So, they cannot exceed 40 hours of flight in 7 days, including a 24-hour break. Okay. Similarly, there may be some requirement that for every 4 hours away from home, you will get a additional salary of 1 hour. So, these kind of constraints have to be factored in when scheduling is planned. Okay. Now, things never go as per plan, and there are always disruptions. There are always situations when the scheduling that you plan does not work and there are delays which are unavoidable. So, this leads to schedule disruption, and disruption management is an inherent part of scheduling, because it is very well known that there will be disruptions. If a schedule is not robust and if it does not have margin for handling disruption, then it will lead to a chain reaction effect, and that is completely it can lead to huge loss, both loss of face as well as financial loss to the airline. Okay. So, let us look at how, while building the schedule, certain strategies are followed to ensure that the effects of disruption are minimized. Disruptions happen because of uncertainties, so they cannot be predicted in advance, and they lead to schedule perturbations or schedule changes, right. Now, these changes come up in the form of delays, cancellations or rerouting of the aircraft. Now, as I mentioned, there can be a propagation of this delay because of chain reaction effect. One particular aircraft is delayed, so it arrives late, so the next one gets delayed, etc., and that can have a chain reaction. Because of this, the operating cost will go up, and also there will be a loss of goodwill, because if an airline is very much prone to delays, if its aircraft are generally delayed, it comes to the notice of the general public, and then the airline ratings go down. So, during a competitive operational between various airlines, the ones which have got a better goodwill or better image in the market of having less delays or better disruption management, the passengers will prefer those. Okay. So, there is an important aspect called as schedule recovery. If there is a disruption, how do you recover your schedule? And this can be done in many ways. So, one way is to do a reactive disruption management. That means you react to a situation and do something so that the schedule is recovered. The other way is called as robust schedule planning. In robust schedule planning, you build in already proactively certain strategies which are going to help you for disruption management. Okay. So, one is reactive, that means delays have happened, now we have to recover somehow by doing certain things. The other is in advance, a priori we have taken some measures or we have inbuilt certain margins in our schedule, so that the schedule is robust and it can handle some minor disruptions. What are the causes for delays in the operation of airlines? There are many causes. Okay. There could be common causes, there could be some uncommon causes. Okay. What are the common causes? Many times delays occur because of ATC restrictions, air traffic control restrictions or air traffic control related issues. Then adverse weather is a huge problem in affecting the schedules of airlines. There could be strikes or industrial action by various crew members, and there could be late arrivals. It could be that there are connecting passengers who are delaying the departure of the next flight because they have to be catered. See, it is not very easy for an airline to say that because the previous flight is delayed, I am going to ignore the connecting passengers and just proceed, because it may fly half empty because of that. So, the number of the connecting passengers who are coming, they are going to various destinations at the end. So, sometimes an airline would delay the departure of a connecting flight to accommodate late arrival of the passengers. Sometimes there is a late arrival of the crew members. Okay. Either the crew member is stuck in traffic while coming to the airport, or in between the two flights also there could be some problems. Then there could be delays because of catering. The catering truck may arrive late, the catering truck may discover that certain things are missing, it may have to rush back and get it. So, that could be the reason. There are many reasons for late arrival. There could be baggage handling issues. There could be a situation that the baggage of the connecting passengers is lost or misplaced, and therefore, they spend some time retrieving it. Beyond a particular time they will not wait, they will say do not worry, we will send it by the next flight, but we cannot keep delaying it extensively. And then there are going to be restrictions because of the maximum takeoff weight, because a larger aircraft may transfer more passengers, but then you cannot carry all of them in the subsequent flight because that is a smaller aircraft. So, that also could cause delay. There are some uncommon reasons also. For example, there could be faulty onboard equipment, some equipment that is important, part of the minimum equipment list, and that is not working. Now, you cannot fly till that particular thing is taken care. There could be unruly passengers on the aircraft. Some passengers get drunk and then they start misbehaving. Some passengers are anyway rude in their behavior. So, they have to be offloaded or they have to be taken care of. That can cause a delay. There could be last minute offloading because of a variety of reasons, and there could be a bomb scare. Because of a bomb scare, now the whole aircraft has to be evacuated, inspected, searched, and then passengers have to be reboarded. It can cause a delay. So, these are some uncommon reasons, but there are also many common reasons. So, therefore, the schedule has to be stable. It should be able to withstand certain shocks, and it should also be reasonably flexible. So, how do we ensure that? Because why should it be stable? Because flights occur across various time zones. The people who are available at the station or at the airport to support the operations could get delayed. There could be changes in the equipment turnaround time. Of course, the turnaround time is generally expected to be a particular number, 30 minutes, 20 minutes, whatever, but it can be more than that. And there is a chain reaction effect. The previous aircraft has arrived late, therefore, the connecting aircraft has to wait, and because of that there is a delay at all the segments. Okay. So, let us look at some simple disruption management schemes. We will abbreviate them as DMS. As I mentioned, there are two basic schemes, a reactive DMS and a proactive DMS. In the reactive DMS, you are responding to a delay which was unplanned. In a proactive DMS, you are providing features in your schedule so that any possible delay will not affect the schedule a lot. So, if there is a delay, you can delay the next flight or even cancel a flight, or you could reroute the aircraft and or the crew members, or you could use reserve crew. Large airlines which have lot of operations always have some reserve crew members who will take care of the absence of a regular crew member for whatever reason. People can fall sick in the last minute, people can have some issue in the last minute, there can be a family problem at the last minute. So, they do not turn up for duty, they take unplanned leave. So, the reserve crew members are useful in taking care, they are available at a short notice. Many a times there is an agreement that certain times you will be on duty and certain times you will be on standby, and when you are on standby, you are expected to be able to arrive at the airport at a very short notice to take care of the requirement. Similarly, as I mentioned to you, we can deadhead the crew members, that means we can use crew members for the next particular flight operation. You send them as passengers and then they take over. In proactive DMS, what we do is we increase the turnaround time to put a buffer against the delay. While all airlines try to minimize turnaround time because that is time on the ground, which is a wasteful expenditure as far as the airline operations are concerned. However, by putting some buffer against delays in turnaround time, you are making the schedule little bit more robust. So, if you know by experience that this particular location experiences more than an average turnaround time, or if your experience shows that there is generally a delay at this particular place at this particular time, you can artificially actually increase the turnaround time between two flights more than what is minimum required to create a buffer against delay. Then you can also minimize the impact of propagated delays. So, if the previous flight came 15 minutes late and the next flight is of 2-hour duration, the crew members can be requested to fly a bit faster, so that they can recover those 20 minutes and subsequently the delay is not propagated. Okay. Then aircraft swapping. For example, if one aircraft has arrived late, there may be an aircraft of the same size already available which is meant for the later flight. You can use that aircraft for this flight, and when this aircraft arrives, it can do the duty of the other aircraft. So, you can swap the aircraft, but this is only possible if and only if the aircraft of a same type or a similar capacity is available. Okay. Let us look at the equipment assignment and types of schedules. One can have an aircraft or an equipment on schedule service, or we can say it is an extra session or an additional aircraft to take care of excessive passenger demand, or you can say it is allotted to a charter flight where you can have dedicated demand for a particular route. Aircraft could be out of service for major overhaul, as I mentioned, for check C, check D, or for maintenance checks, or for training, because crew members have to be trained, and when they are trained, it may not be possible sometimes to, many a times training takes place in a normal flight because the captain can be training the first officer for certain duties like route planning or like weather avoidance type of duties, but sometimes you may have to use your aircraft to train the crew members, especially for example when the monsoon season starts, you may need to train them for flights with water accumulation or wet runways. And then there are special projects. Sometimes you want to take the aircraft out of service because you want to install different seats or better seats. All of that will make the aircraft out of service. So, an aircraft or an equipment can be either in service on various duties or it could be out of service. Then some aircraft, as I mentioned, is always used as, just like we have extra crew members or reserve crew members, major airlines also have line reserves or they have extra aircraft not normally used for flights for any emergency requirement. Now, this is very expensive for a small airline to do, but it is useful and required for an airline with massive operations. There are also some limitations because of ground operations and facility. Aircraft operate from airports and airports have a limited facility. Okay. So, there could be a problem because of gate positions, and you need to have extra for delays and early arrivals. Sometimes aircraft arrive early, and when they arrive early, they have to be connected to a gate. The gate may not be available. So, they will be waiting for the gate to be free, or they may have to be reassigned to some other gate if it is available. Then you may not have enough ticket counter space to check in the passengers who are arriving. There may be a transfer of passengers and cargo which takes time, and that has got some limitations on the facility. So, what you can do is you can control the number of flights which are departing and arriving at the airport at any given time by adjusting their departure times. Arrival times cannot be adjusted because they have already arrived. And remember that any delay in arrival or even early arrival can affect the entire schedule. An early arrival aircraft can also affect the schedule in a very bad way. Okay. There could be delay in operations. Aircraft come into approach, and during approach there could be delays at any place. There could be delays because of separation between two aircraft in the air to ensure the wake turbulence. All these things we will study when we come to the air traffic management portion. So, summing up, let us look at what are the key takeaways for airline scheduling. The first point is that scheduling of an airline reflects the competition, the travel demand, and also which kind of route you are operating. Are you operating hub and spoke network, or are you operating point to point on? So, all these things, they directly are reflected in the schedule that you offer. Then the job of lead assignment is to maximize profits, and how do you do that? You minimize the risk with different fleets because the demand is uncertain. So, you have a different capacity aircraft available which you assign to various routes depending on how the demand is predicted to be changed. So, that is why assignment of fleet can help in maximizing the profits. Then the routing of the aircraft ensures that the operations are efficient by synchronization, synchronizing flights with the aircraft, crew with the aircraft, and synchronizing all the players together, so that there is a, while there is a margin for any disruption, it will be done in such a manner that there is optimization. Now, airline crewing is a very complex problem. There are lots of constraints, either because of the crew bargaining arrangements over and above the regulatory requirements. So, therefore, a lot of mathematical modeling is used in fleet assignment, aircraft routing, and airline crewing. Okay. It is a huge research area in operations research, OR, and many techniques are used. Finally, the schedule can never be considered to be always met. There will be unplanned delays and disruptions, and the tactics that you follow could be either reactive or proactive, as we have seen. So, in short, airline scheduling is a very complicated and very intensive activity. It can directly affect the bottom line of an aircraft, it can directly affect the bottom line of an airline, and therefore, it is very important to do it. It is prone to a lot of mathematical modeling and simulation. Thanks for your attention.